Hi guys, I just want to take a few minutes today, some very briefly talk about some aspects of leaf anatomy, and then also spending just a little bit more time on some alternative photosynthesis pathways. So the pathway we have talked about um, is found in a great number of plants, but it doesn't work for all of them. Okay, so if we look here at a kind of a cut through of a typical leaf section, we find a couple different layers. We have an outer layer, an epidermis layer. This is typically covered by a waxy cuticle. Right underneath that are some tall, called palisade cells, because they kind of look like the palisade outside of a castle. These vaguely rectangular cells, these are where the bulk of the photosynthesis takes place. Underneath that, you have some spongy tissue that also that has lots of gas space in it. So this is where your oxygen will flow out and your CO2 can flow in. The xylem and phloem are the vascular tissue of a plant, and then you have a lower epidermis. So buried in this lower epidermis are these openings in the bottom of the cell, and they open and close in response to the plant's need for CO2 and to prevent water loss. It's kind of a neat application of osmosis here. When they want the stoma to close, they pump ions into these guard cells that surround the opening. Water follows, they swell shut, and the gas, the opening shuts. All right, so if we think about our typical pathway of photosynthesis, we have a fixation step, okay, where we're taking gaseous carbon in the form of CO2, we combine it with a 5-carbon intermediate, and then we get a 6-carbon intermediate that pretty quickly that makes a 6-carbon that degenerates, or excuse me, gets converted into 2 3-carbon phosphosugars here. Okay, this enzyme that catalyzes this is Rubisco. It's a shortening of a ribulose bisphosphate carboxylase. This is probably the most common enzyme on the planet. And it works very well to fix carbon dioxide the vast majority of the time. If, however, you're a plant and you are in some situation where photosynthesis is not optimal, for example, where you don't have a ready supply of CO2, you have lots of oxygen, and also if you have operating at high temperature, you can get something called photorespiration, and this is where your 3-carbon intermediates actually break down back into CO2. And this obviously is a wasteful process for the plant. It's not ideal, and so plants have evolved mechanisms to slow or reduce the amount of photorespiration that goes on. Okay, so one pathway to do this is called the C4 pathway, and this is found in, I believe, in plants like corn, and it uses a 4-carbon intermediate to hold the CO2 in order to feed it then into the Calvin cycle. Okay, so it takes an intermediate of metabolism, pyruvate, converts it into PEP, which I believe is phosphoenol pyruvate. And then this enzyme PEP carboxylase takes a carbon from CO2, trades it for that phosphate, and then your CO2 is hiding here in this 4-carbon intermediate. So this is where we get the name C4 for this pathway. Okay, a few more enzymatic conversions, and then this CO2 can be released to go back into Calvin cycle. Okay, and how this works is you can get some cells that are storing this CO2 and other cells that are taking up these intermediates that have the stored CO2 and performing the Calvin cycle. The nice thing about this is then the Rubisco in these cells does not overload on oxygen, and therefore the Rubisco is working efficiently. Okay, so the first example we talked about, the typical C3 pathway, you have in the same cell, you have CO2 coming in through Rubisco, being fed into the Calvin cycle, and sugars being produced. You also have, in the C4 pathway, you have one cell holding the carbon in the form of that 4-carbon intermediate. Then this intermediate travels to another cell, releases its CO2, then you can feed Calvin cycle. There's also another pathway, somewhat similar. This is called the crushylation acid metabolism pathway, or CAM pathway. And here what you have is at certain times you are you're converting CO2 into these organic acids that contain CO2, and then so you're taking in CO2 at night when the heat is less and your water loss is less, and then during the day when you want to photosynthesize, you can liberate the CO2 from these organic acids and then feed your Calvin cycle. All right, so I think it is important just to be aware of these alternative pathways that plants have evolved to be efficient in their photosynthesis. I'm trying to find some ways to have you guys be accountable for watching these videos. So what I'm going to do is pose these 3 questions for you, and then you'll see a Schoology quiz of the same title as this video. You won't see the questions on the quiz. You'll have to have this open, and so you'll have to take that quiz as part of your homework grade. All right, thank you very much. We'll see you soon.